Okay, class, picking up where we left off at, we were supposed to write this parenthesis twice. So it's 2 times the fifth root of n plus the square root of n. And now we do the distributive property or FOIL method. This will give us 4 the fifth root of n squared plus 2 the fifth root of n times the square root of n. And then this will be plus 2 fifth root of n square root of n. And then finally plus the square root of n squared. Okay, now if we look here, before we do anything to these fifth root of n's and square root of n's, if we notice here, these are like terms. But before we do that, we know that this 4 fifth root of n squared will stay the same. We can combine these two here. And this is supposed to be a plus. Okay, so we would end up with plus 4 the fifth root of n square root of n plus the square root of n squared is just n. Now, the next thing we need to do is this here. We know we're going to have to combine these two values here. So we will have 4 the fifth root of n squared plus 4. This would be n to the 1/5 times n to the 1/2 plus n. Now we know the common denominator of 5 and 2 is 10. So let me write this again. So this would be 4 to the n, this would be 2 tenths, and then n to the 5 tenths plus n. Now we know 2 tenths plus 5 tenths is 7 tenths. So it would be 4n to the 7 tenths power plus n. Now if we want to write this as a radical, which we should, and we must, this will give us 4 the 10th root of n to the 7th power plus n. And this is our final answer. Now, we need to scroll on to 9.3, dividing radical expressions. Okay, dividing radicals. Create an expression that satisfies the following criteria. No perfect nth powers under the radical, no fractions under the radical, and no radicals in the denominator. Eliminate by rationalize the denominator. Now, how to rationalize one-term denominators? Multiply the top and bottom of a fraction by a factor that creates a perfect nth power in the denominator. Okay, you're going to see what this means as we go through the problem. Okay, now the first thing, we have the square root of 100 over 25. Since this whole fraction is under square root, why don't we just divide that? Wouldn't that give us just the square root of 4, which is just 2? Now we come here. The square root of 400x cubed y over 4xy to the 5th. 400 divided by 4, we know is 100. And then we have x to the 3rd divided by x, which will give us x squared. And y over y to the 5th will give us y to the 4th in our denominator. Now I made one little error. I should have made this radical more like this to cover the whole fraction. So now we look here. The square root, we could break this up as the square root of 100x squared over the square root of y to the 4th. The square root of 100 is 10. The square root of x squared is x. And the square root of y to the 4th is y squared. Now we come down here to c. We have the square root of 3/5, which is the same as the square root of 3 over the square root of 5. Now we know we cannot have a square root in our denominator. So we'll multiply the numerator and denominator by the square root of 5, because we know the first thing that would make this a perfect square is to multiply by the square root of 5. So the square root of 3 times the square root of 5 is the square root of 15. Square root of 5 times the square root of 5 is the square root of 25. And we know this would be the square root of 15 all over 5. Okay, next, we come here. We have 5 times the square root of 7 over the square root of 2x. We know to make this without this radical, we have to multiply the numerator and denominator by the square root of 2x. Now, our numerator, it will give us 5 times the square root of 14x. And then here at the bottom, the square root of 2x times the square root of 2x will just leave us 2x. And this will be our final answer here. Now, we come down here to e. Now with e here, we have 3 plus the square root of 5 over the square root of 8. Now we need to get rid of the square root from the 8. So we multiply our numerator and denominator by the square root of 8. And this will give us 3 square root 8 plus the square root of 40 all over square root of 8 times the square root of 8 will give us 8. Now, here's the thing here. We have a perfect square in the square root of 8. So this would be 3 times the square root of 4 times the square root of 2. Plus we have a perfect square in the square root of 40. We will have the square root of 4 times the square root of 10 all over 8. So we know the square root of 4 is 2 times 3 is 6. So we have 6 square root of 2 plus the square root of 4 times square root of 10. This will give us 2 square root 10. And this is all over 8. Now 6, 2, and 8, they all have 2 in common. So this will give us 3 square root of 2 plus the square root of 10 all over 4. Now we come here to f. Now, if you notice here in our denominator, we have the square root of 6m. To get rid of that radical, we'll multiply the square root of 6m to our numerator and denominator. So this will give us 2 times the square root of 18 mn all over. We will have 5 times the square root of 36m squared. Now, with our numerator, we know that there's a perfect square in 18, which is 9, and that will leave us 2mn in the other radical. Now, our denominator, we know the square root of 36 is 6, square root of m squared is m, so it'll be 5 times 6m, which is 30m. Now, we know the square root of 9 here is 3, so 2 times 3 is 6. So we will have 6 times the square root of 2mn all over 30m. Now we know that 6 and 30 both have 6 in common. So our numerator would be the square root of 2mn all over 5m. And that is our final answer. Now, this next page is not required, but it will help you with your homework. Okay, so we come here. We had a cube root of 343 over 125. We could break this up as the cube root of 343 and a cube root of 125. And this will give you 7/5. Now we come here. We could do the same thing. But before we do any of that, let's see if we can simplify. A to the 5th divided by a squared will leave us a cubed. And b squared divided by b will leave us b. Now we know the cube root of a to the 3rd is just a. And we cannot take a cube root of b, so it'll be the cube root of b. So this will be our final answer. Now we come here to c. We had a cube root of 4/3. Now this breaks up to the cube root of 4 over the cube root of 3. Now remember, we're not trying to find what makes this a perfect square. We're trying to find what would make this a perfect cube. And we know if we multiply this by the cube root of 9, This would make it a perfect cube because the cube root of 27 we know is 3. But our numerator, it'll be the cube root of 36 all over the cube root of 3 times the cube root of 9. We know is 3. So this is our final answer. Now here we have 4 to the 4th root of 54. So we need to multiply this by what would make this a perfect 4th root. Now we will have to multiply the numerator and denominator by the 4th root of 24. And this will give us 4 times the 4th root of 24 all over. This will end up being 3. So this is our final answer here. Actually, this should be 6. The 4th root of 54 times the 4th root of 24 would be 6. So we'll divide both by 2. And this will be 2 times the 4th root of 24 all over 3. Now we scroll down here to E and F. Now for E, we have the cube root of 5 over 12x. So now we will break this up as the cube root of 5 over the cube root of 12x. Now, first of all, we know the cube root of 12 is actually, we could break that up to the cube root of 18x squared that we will multiply our numerator and denominator by. And this will give us the cube root of 90x squared all over. This will end up being the cube root of 12x times the cube root of 18x squared will give us 6x. And this will be our final answer. Now we come here to F. Now we're dealing with these 4th roots here. Now with this 4th root, we would need to multiply the numerator and denominator by the 4th root of 3, or actually it should be 9ab squared. So it'll be the 4th root of 9ab squared. So this will give us 2a times the 4th root of 9ab squared all over. This would end up giving us 3ab squared. Now these a's will simplify out. You have 2 times the 4th root of 9ab squared all over 3b squared. And this will be the final answer. Now we come down here to G and H. Now with G, we will have the cube root. Well, first of all, let's simplify this. 5 and 10, we know both of them have 5 in common. So this will be a cube root of 2 will be in our denominator. These x's will simplify out and leave x in our denominator. And we'll just have y in our numerator. Now, we'll multiply our numerator and denominator. Well, first, we have to break this up to be the cube root of y over the cube root of 2x. And we have to multiply numerator and denominator by 4, the cube root of 4x squared. And this will give us the cube root of 4x squared y all over 2x. And then last but not least, we will multiply, well, we can combine this. We can actually take the cube root of 8 on our denominator. And cube root of 8 we know is 2. And that will leave the cube root of np squared. Now we know we will have to multiply the numerator and denominator by the cube root of n squared p.